Shri Sai Ram. Dear learners, welcome to part 7, that is the last part of algebraic expressions and polynomials. Before we begin today's session, let's hear another story. There were two brothers. One was very successful, highly respected in society, while the other brother was a drunkard and a drug addict. He would often beat his family members. How come two brothers brought up in the same environment have such different attitudes? The second brother, who was a drunkard, was asked, "Why do you behave this way? You are a drug addict, you are a drunkard, you beat your family members." This man replied, "What do you expect out of me? My father was a drunkard, he was a drug addict, he would often come home and beat us. So that is why I am what I am. I am following my father's footsteps." The same man asked the first brother, "From where do you derive your motivation? You are so successful in society." The first brother replied, "When I was a little boy, I would often see my father coming home drunk and beating us. And I decided at that time, when I grow up, I'll never be like that." So just see, learners, same source, but how different the motivation is. For the first brother, the motivation is very positive, while for the second brother, the motivation is negative. As human beings, when we tend to take the negative motivation, it might be the shorter path, but in the long run, the journey is very, very tough. So we need to be very wise in choosing what path do we take. So let's come back to our topic on algebraic expressions and polynomials. Last time we had done remainder theorem. Today we are going to do factor theorem. In the last question that we did in part 6, you were asked whether the given algebraic expression is a factor of the given polynomial or not. So what did we do? We found the remainder, and if the remainder is 0, we would call it a factor. So it is the same thing, only the difference between remainder theorem and factor theorem, you see, we have to see what the remainder is. If the remainder is coming 0, like this here, remainder is coming 0. When we put x is equal to a in the given polynomial, then we need to check the remainder. If the remainder is coming 0, we will say x minus a is a factor of px. If you remember, x minus a, we would equate it to 0, x is equal to a. So if x is equal to a, when we put its value in px and we get the remainder 0, then we will say that x minus a is a factor of the given polynomial. And the converse will also be true. if x minus a is a factor of px, then remainder will be 0 when x is replaced by a in the given polynomial. Let's do some examples to see this. Here we are given px is equal to x cube plus 3x square plus 5x plus 6. And we have to see whether x plus 2 is a factor of px. So we first equate x plus 2 equal to 0. X is equal to minus 2. Put the value of x as minus 2 in the given polynomial. See what do you get. I have put the value of x as minus 2. Solve is minus 2 whole cube is minus 8. Then we get minus 2 square is plus 4. 5 into minus 2 is minus 10 plus 6. If we simplify it further, we will get 18 minus 18. So 18 minus 18 is 0. Since our remainder is coming 0, we will say that x plus 2 is a factor of px. So in factor theorem, we have to ensure that our remainder has to come 0. If the remainder is 0, then the given algebraic expression will be a factor of the given polynomial. Let's do another question here. In this question, our px is 4x cube plus 3x square minus 4x plus k. And we are already given that x minus 1 is a factor of px. This is given to us. So what does this mean? That if I equate x minus 1 to 0, x will come 1. And if I put the value of x as 1 in px, what will be the remainder? It is already given that it is a factor. If it is a factor, that means the remainder will be 0. When x is replaced by 1, the remainder will be 0 because in the question itself it is given that it is a factor. So now let us put x as 1. So 4 into 1 cube, 3 into 1 square, 4 into 1, k as we will copy as it is plus k. This is equal to 0. It is given to us. Now solve it. When we solve it, we will get the value of k. So we get it 3 plus k is equal to 0. So k is equal to minus 3. I hope the question is clear to you. You can put the value of k as minus 3 and divide the given polynomial by x minus 1. And you will get the remainder 0. Now let us do a quick recapitulation of what we did in this chapter. If you remember, in this particular chapter, we had talked about variables and constants. I showed you one GIF where a train was moving and you had to identify what are the things that are moving and what are the things that are stationary. So all those things which remain fixed, they are referred to as constants, and the things which keep on changing. They are called variables. And when we are talking of algebra, in algebra, variables are denoted by x, y, z, and constants will be numbers. Sometimes constants, like in the last question, k was a constant. In another question that we did, a was a constant. So we should be clear how to distinguish the same. When it is constant, constant will have only one value. Variables can have different values. Apart from variables and constants, we discussed algebraic expressions, and when we were discussing algebraic expressions, we also focused on what are the terms of an algebraic expression. The algebraic expressions can have one or more than one terms, and each term was separated by a mathematical operation. Then we discussed to identify polynomials as a special case of algebraic expressions. Do you remember? When does an algebraic expression become a polynomial? The denominator cannot have the variable. Variable should always be in the numerator of the algebraic expression. The power of the variable should be a natural number. It cannot be fractions. So these were the main conditions. For example, if I write down 1 by x, it is not a polynomial. On the other hand, if I write down x square plus y, yes, it is a polynomial. Then we did types of polynomials. In this, we talked about monomial, binomial, trinomial based on the number of terms. If one term is there, it is monomial. If two terms are there, binomial. If three terms are there, trinomial, and so on. And we also discussed the types of polynomials on the basis of their degrees. We discussed degree 1, degree 2, and degree 3. If the degree of the polynomial was 1, it was called a linear polynomial. If it was degree 2, it was called a quadratic polynomial. And if the degree of the polynomial was 3, it is called a cubic polynomial. And I hope that the degree of the polynomial is clear to you. When we are talking of, suppose you are given a polynomial x square plus y plus 3x. First of all, how many variables are there? There are two variables here, x and y. What is the degree? This term has got degree 2 plus 1. Degree is 3. So degree of the polynomial is the degree of that term which has got the highest value. So we talked of types of polynomials, and after types of polynomials, we discussed like and unlike terms. If a polynomial is like this, which are like terms? All terms which have same variables, they are called like terms, and if we take these two, they are unlike terms. Then we discussed value of a polynomial, how to find the value of the polynomial, and also the zero of the polynomial. That means when we are finding the value of a polynomial, so given polynomial is there, we have to find the value at a particular point. So whatever point is given to us, if it is given x is equal to 1, put the value in the given polynomial. Whatever answer you obtain, that will become the value of the polynomial. When we are talking of zero of the polynomial, is your answer coming 0 after putting that value or not? If it is coming 0, we will say it is 0 of the polynomial. It is very much similar to the factor theorem that we have done, that remainder should come 0. Apart from this, we learnt to perform 4 different operations on polynomials. One was addition, then subtraction, multiplication, and division. We have done a lot of questions based on all the 4 mathematical operations, and we have done a variety of questions. Please practice them again. So that is all. With this, we have concluded the chapter on algebraic expressions and polynomials. Thank you so much. Om Shri Sai Ram.